All right, AQR students, we're finishing up student activity sheet 4 that we started yesterday. And so we have road to $1 million here. Number 6 says Blaine wants to have $1,000 in 10 years. The following are the choices in which he can invest. There's a savings account earning 3% compounded quarterly, a checking account earning 1% compounded monthly, a money market account earning 4.5% compounded semi-annually. Blaine plans on making no withdrawals or deposits for 10 years. So he's going to start with just put a lump sum of money in. Once in 10 years, it should be worth $1,000. So rewrite the formula from question 3 for present value, allow for any compounding period. So this was our formula for future value. I want to solve it for present value. So this over here, 1 plus I over n to the nt power, is just some number. So if I divide both sides by that, 1 plus I over n to the nt power, 1 plus I over n to the nt power, then it's going to cancel out, and I get present value equals the future value divided by 1 plus I over n to the nt power. Okay? So what you're going to do is I want you to take these three accounts, put in the rates, 3%, 1%, 4.5%. Compounded quarterly means 4 times a year, that's your N. Compounded monthly, 12 times a year, that's your N. Semi-annually, 2 times a year, that's your N. Figure out how much he needs now, your present value. Future value is going to be $1,000. 10 years, T is 10. Plug it in. See what different amounts of money he needs for each of these. Okay? Figure out the amount of money he needs for the savings account to end up with $1,000 in 10 years, a checking account, and the money market account. Then, what we want to do is just the second, you don't have to graph this, but the second part of number 8, which factor has the most significant effect on the situation? Which is more important, the interest rate or the compounding periods, and how can you tell? All right, and then finally, in which account should Blaine invest? And that will wrap up student activity sheet 4. Okay? All right, AQR students, so we're looking at student activity sheet 5, a cool tool. So Vanessa is a financial planner specializing in retirement savings. She realizes the importance of using mathematical formulas and the appropriate tools to help her clients understand the reasoning behind the advice she is giving. Okay? One of her favorite tools is the time value of money TVM calculator. In student activity sheet 4, you met Josephine, one of Vanessa's clients who wanted to retire with $1 million in savings. Josephine's initial situation, she plans to retire in 50 years, number of years until maturity, 50 years, with $1 million in savings. All right? This is a million here. This is a comma. $1 million is the future value. Vanessa advised her to find an account that earned at least the current rate of inflation, so we're going to go with 3% compounded monthly, 12 times a year. Okay? So, in the calculator, in your calculator, what you want to do is, there's an apps button right here. It's right below, you have the second column of buttons, you have mode, xt theta, and then apps. Press apps. Number 1 is, they only have one app in there, which is finance. Press enter. We're going to use the TVM solver, number 1. Press enter. All right? Now, I was messing with this, so some of the numbers are already in. Yours are probably not in there yet. So for N, capital N is the number of compoundings we're going to do over the whole lifetime, which is going to be little n times little t, 12 times 50. And you can actually type it in that way. We can say 12 times 50, press enter, and it tells us you're going to do 600 compoundings over this 50 years. All right? My percent interest rate is 3%. You don't need to change it to a decimal, just leave it as a 3. Present value is what we're looking for. The principal or present value is the question mark here. Don't know what the present value is. All right? The future value, though, is $1 million. All right? And in compoundings per year is 12, and I think you need, PY stands for payments per year, which we don't have, but these need to be the same, I think. So we're going to put PY12, CY12 also. Now we're going to put the cursor on present value because that's what we want to solve for. And to solve it, you can see right above enter in green it says solve. We're going to press alpha and enter, and it tells us negative 223. All right? Negative 223, 548, 22. That is the present value needed. You pay in other words, if Josephine pays negative 223, 548.22, in 50 years, she's going to get coming back to her $1 million. Okay? So that's how we use, and we're going to be using this TVM calculator quite a bit over the next couple lessons here. All right? So let's move on. Let's look at another example. Vanessa uses a TVM calculator to help Josephine understand how the different variables affect one another. Identify the values in Josephine's situation for each variable the TVM calculator uses. Oh, this is what we just did. Okay? This is what we just did. All right, so we don't have to do it again. We did that. Find the present value of the investment required. All right, how's this amount compared to student activity sheet number 4? Should be the same number. Don't remember what we got. Well, we had different, we had different numbers there, but yes, it should be the same amount. All right, so I'm going to do one more of these with you, and then I'm going to let you do the rest of these. I think that, we're going to do up through number 6 here, okay? So number 4, let's do number 4. Reginald wants to find the future value of an investment of $6,000 that earns 625 compounded quarterly for 35 years. He wants the future value. All right, so my capital N, well, let's put it, my capital N, number of compounding periods, this is going to be compounded quarterly 4 times a year for 35 years. So if we type that in up here, 4 times 35, we can see that this is equal to 140 periods, compounding periods. The interest rate is 6.25%. The present value, it's worth $6,000 right now. No payments. This is what we're looking for. Question mark is the future value is what we're looking for. No payments. We have 4 compounding periods per year. All right. So we're going to have 6.25%. We're going to have 6,000 here. And I'm going to put 4 on PY and CY here. And then I'm going to come up to future value. Now, the present value and future value will always be different signs. I'm just going to tell you that. If I put a positive in here for the present value, my future value will be negative, and vice versa. If I put negative here, I'm going to have a positive here. They'll be the same numbers, but just different signs. So I'm going to hit alpha, enter, and I get 52,580 and 51 cents. Okay? So that's that future value in 35 years of the 6,000 you started with. All right. All right. So you get hopefully you get the idea here. Go on it. I want you to do number 5 and 6. Okay? And then we'll hold off on this until Friday. We'll finish this up on Friday. All right? Hope you're doing well. Let me know if you have any questions. Bye-bye.